So, second topic natin is nuclear chemistry. So, nuclear chemistry. Nuclear chemistry is the subdiscipline of chemistry that is concerned with the changes in the nucleus of the element. So, last time pinag-usapan natin ang mga uri ng reaction. So, they are different actually with nuclear chemistry. Nuclear chemistry involves reaction that involves the nucleus itself, but upon normal chemical reactions, ang pinag-uusapan natin dun is the action of electrons. So we have the normal reactions like synthesis reaction, which concerns maybe transfer or sharing of electrons. So nagkakaroon ng in a chemical reaction, nagkakaroon ng chemical bond because of electron sharing mainly, and donating and accepting electrons. But in nuclear chemistry, it is quite different because in nuclear chemistry, ang pinag-uusapan natin dito is yung mga transmutation changes and the changes that involves the nucleus itself. So yeah, so the nucleus itself. And just to give you a little bit of a review, so kung naaalala ninyo ang inyong general chemistry subjects on senior high, so we have the nucleus here. So the nucleus is the central part of the atom, if you remember, which actually houses the neutrons and the protons, right? And the swirling particles around him is the electrons. So there, ganyan yung ating labels. So in a nuclear chemistry per se, a process in which two nuclei or nuclear particles collide to produce different products than the initial product. So in this process, involved na actually dito ang maybe, let's say, banggaan ng neutrons, banggaan ng nucleus. Pwedeng magsasama yung yung dalawang nucleus and together with the subparticle. So there's basta the reaction is actually concerning the nucleus of an atom. So nuclear reaction versus chemical reaction, just what I stated earlier. So a chemical reaction involves electrons, nuclear reaction involves the nucleus. So yun ang difference nila mainly. And nuclear reaction involves tremendous amount of energy. So in a normal chemical reaction, hindi compared to the nuclear reaction, hindi ganun kataas ang energy na involved. Pwedeng comparatively low with the chemical reaction. Nuclear reaction may also violate the law of conservation of matter. There is actually a explanation here because pwede kasing ang mga nuclear reaction is induced or artificial. So with this, the nucleons or the particles that found in a nucleus may be conserved, may be transformed into energy, which is actually a theory of Einstein. So that's it. Chemical reaction looks like this. So we have here the reactants and the products. So yan. Kaya nga lang, as we have mentioned earlier, in chemical reaction, for this to happen, so we need to break the bonds or the bonds here of the H2 and the O2. The bond is actually made by the sharing of electrons here between the two. So we need to break those and reform those bonds into H2O. So that is a chemical reaction looks like. So, but in nuclear reaction, we have here from this into that. So we are concerned in a nuclear reaction. We are concerned with the nucleus here. So we are talking about the nucleus of a radium transforming into a radon and this alpha particle na pag-uusapan natin later on. So let's take one species here. So this is called a nuclide. So in a in a chemical reaction per se, so we have here the species. We actually pertain to them as a compound or an element. So in here, in nuclear chemistry, we are pertaining to the species as the nuclide. A nuclide is actually a specific nucleus of an atom. So it is a unique nucleus of an atom. So we have here three parts. So parts of a nuclide is actually has a symbol, this symbol radium, and the atomic number on the bottom left, 288, and the atomic weight here, the 226. Actually, this atomic number and atomic weight, makikita nyo yung mga values na yan sa periodic table. So you need to have a periodic table. So the general symbol for this is the general representation here is a AZX. So X represents the symbol, the Z represents the atomic number, and the A represents the atomic weight. Okay. But again, just to note, sometimes ino-omit natin tong atomic number because the symbol is actually given. So there is actually a reason for that. So ibang box, hindi na nila sinasama yung atomic number, just the symbol. But in my examples, I will be including the atomic number. So then the nuclides represents the species in a nuclear reaction. Nuclide symbol, which is the X, kanina, depends on the atomic number. Ganito. So if we have to determine the symbol of a nuclide, so ang titignan natin is yung atomic number. Kung ano yung specific atomic number niya, yun ang kanyang element symbol. So the atomic number represents the number of protons. So kung ilan yung proton doon sa ating nuclides, yun din yung ating atomic number. So ibig sabihin, the proton is equal to the atomic number, right? The atomic weight of the nuclide, which is the A, represents the atomic number and the neutrons, meaning the A, which symbolizes the atomic weight, is actually the proton plus neutron. Tandaan, this A represents the proton plus neutron. So they are the sum of proton and neutron. And again, if we go back to the video here, that pretty sums up the nucleus, right? Because we have here proton and a neutron. Hindi natin kino-concern muna yung mga electrons natin. So let's go back again. Let's quickly swipe presentation. Okay, so let's try to have a sample questions here. Okay, so we have here 3 nuclides. So binigay sa atin yung atomic weight, which is the proton plus neutron, and this one we are also given with the atomic number. So our mission is to determine the symbol of each nuclide. And napag-usapan natin kanina na yung symbol ay depende kung ano ba yung ating atomic number or yung Z value. So for this, we need to consult a periodic table, diba? Kasi we do not know kung ano ba yung nire-represent ng mga atomic numbers natin. So ang mission, if you are actually determining the symbol of each nuclide, you need to know this atomic number. So let's try to search for it. Meron ako nakahanda periodic table dito. So 92. So we have 92, 53, and 43. Okay, let me check that muna. Ayan. So let's click this periodic table na nakaset up. Okay, so ang babalikan natin ay 92, 53, and 43. So let's go back. Number 92 is here on the actinide series. So we have here uranium. uranium. Kita niyo na, kita niyo to. I'm sorry, I will try to, there, 92. And another one, sorry, makakalimutan ko. So, 53 and 43, let's look for, first we need to write muna natin. So this is uranium, ano? So uranium. So let's try to look at number 53 and 43. Number 53 and 43. Ito yung number 53. The 53 is actually here. Number 53, the atomic number is 53, so it represents iodine. So, and number 43 is ito. So, the technetium here. So, let's try to write that down. So, this one is actually iodine. And this one is technetium. Right? So, let's check muna kung just to make sure. Technetium. Is that the technetium? Yes, it is a technetium. So let's go back. Okay, so the unknown is U, uranium, Y is iodine, and the Z is actually the technetium. So let's try to show the, I'll be showing the answer kung tama. Ano, let's check. Okay, that's correct, guys. So the first one here is uranium, the second is iodine, and the technetium, the third one is the technetium. So gano'n natin siya tinitingnan kung ano ba yung symbol ng mga nuclides natin. So unang-unang titingnan natin is yung atomic number. So actually isa ito sa mga pinaka sikat na radioactive compounds. So, radioactive atoms na itong we have here on the uranium pellet, ginagamit yan sa mga nuclear power plants. We have the iodine 131. So, hinahalo ito sa mga treatment, especially sa goiter. I think that's goiter. So, not sure. But you can actually search the literatures regarding the use of iodine 131. And we have also the technetium 99. Technetium 99 is actually used especially in diagnosis. Chinecheck pa natin kung so next step is the nuclear reaction. So we are looking now at the reaction itself. So a type of there are different types of nuclear reaction. We have radioactive decay. Unstable nucleus emits radiation and is transformed into a nucleus of one or more other elements, which in other books and literatures they refer to it as the nuclear fission. So tandaan lang natin, if we have this type of reaction, so we are starting from a bigger nuclide. So from bigger to smaller. Okay. Paano natin masasabi yung mga bigger nuclides? If we look at a compound, let's say X, tapos meron siyang 260, tapos meron siyang, let's say, 90. This one is actually a bigger nuclide because if we look on this atomic weight, masyado siyang mataas. And also, ang mga titingnan natin, kino-consider kasi natin na mga big nuclides o yung mga usual na nag-undergo ng radioactive decay is kapag yung atomic number mo ay greater than or equal to 73. Okay? So, kung nakakita kung meron kang nuclide na ang atomic number ay more than 73, that's actually considered a big nuclide. So, also, we have the nuclear transmutation. So, nuclear transmutation is you start from small to big. So, from small to big. So, this is some sort of a combination. Pagka nag-combine yung dalawang isang nuclide mo with the subatomic particle or another small nuclide, they tend to form big nuclide. So this is actually an animation of ginawa. Ito yung isa sa mga ginawa kong animations. So let's have here a sample parent nuclide. So this is a sample parent nuclide. So there is actually a bombarding particle here, and then ang ginagawa niya is to parang binobombard niya or parang ini-strike niya yung isang given nuclide, which is starting from a bigger one, and this one is called the parent nuclide. Remember, parent nuclide is the starting nuclide, and these ones are called daughters. So parang ano lang yan sa chemical reaction, yung sinasabi natin kanina, yung parent yung parang reactant, tapos yung daughter nuclide natin yung parang product. So that is your nuclear reaction. And sa tingin nyo, we started from bigger one and ended with two daughter nuclide that is two daughter nuclides that is actually smaller. So this one is an example of nuclear fission or radioactive decay. So a radioactive nuclide undergoes decay to produce daughter nuclide that is relatively stable. When we say relatively stable, they have a low energy. So ang tendency kasi ng mga matter natin is kapag mataas yung energy nila, ang gagawin nila is maglo-lose out sila ng mga energies na yon para maging mas stable yung kanilang state. Yun ang tendency nila. Kapag ka naman sila, so mas prefer ng mga atoms natin o ng mga compounds natin ng stable state. So a radioactive decay involves high amount of energy that is released. So ayun, sabi natin yan kanina, and it happens naturally or artificially. So meron tayong mga radioactive decays that is actually a natural process. However, there are also artificial. So ang tawag sa kanila ay induced process. Yun, isang example yung pinakita kong video kanina, in which we are actually bombarding the nuclei. Next is the nuclear reaction examples. So we have here a certain example of nuclear reaction or nuclear decay, radioactive decay. So kung mapapansin natin, we have here a radium transforming into a radon. Ito yung kanina, plus an alpha particle. So starting from a radium, so makikita natin ang taas ng atomic weight niya, 2 to 6, and then it transformed into a radon. This radon has atomic weight of 222. So this is relatively smaller compared to the radium, the parent nuclide. So another one we also have here, the uranium 235 reacting with one neutron. I think this one is actually a bombardment, so parang nag-bombard sila. So upon striking this one, the uranium, so upon striking this neutron strikes the uranium and then splits into a xenon 144 and a strontium 90. So xenon and strontium are the daughter nuclides, which is relatively smaller compared to the uranium, and then meron ka pang byproduct na neutron subparticles, subatomic particles. So that is radioactive decay reactions. So another one, so meron ulit tayo ditong chemical reaction. So we have here a sample 2 hydrogen nuclide. So ano kaya ang gagawin ng 2 hydrogen nuclide natin? So yun, nag-combine, and then it releases energy to form a deuterium nuclide. The deuterium nuclide is an isotope. Ang tawag sa kanya ay isotope. Deuterium nuclide is actually a hydrogen that has a neutron. So ang atomic weight niya ay 2, but ang atomic number niya ay 1. So technically it is still a hydrogen but has a neutron. So again, from starting, kung mapapansin natin, we started from two small nuclides. This is the parent nuclides. transforming into bigger one. Diba? Mas malaki yung deuterium. So this one is an example of nuclear transmutation, nuclear fusion. Okay, so next nuclear transmutation. So here, an element or a nuclide with another element or subatomic particle to produce. It combines actually, hindi ko siya na-edit, sorry. It combines to produce bigger nuclide, just what we saw earlier. This process involves tremendous amount of energy. So the reaction was induced, but actually it can also be naturally happening. It could be naturally happening. Why? Because this nuclear transmutation reaction is already happening on the surface of the sun. Doon sa surface ng sun, alam naman natin na sobrang taas ang energy doon, sobrang init, diba? So, present doon is yung mga hydrogen atoms natin, and then ang tendency is sa sobrang taas ng energy, yung mga hydrogen atoms na yun ay nagko-combine, nag-undergo ng nuclear transmutation to form deuterium. And then, those deuteriums actually reacts with themselves and other hydrogens to form helium. So, papakita natin yung kanilang reaction. So, ito makikita natin na sa pointer. So, this is the examples, some examples of nuclear transmutation. So, we have here a nitrogen reacting with a neutron, forming carbon-14 and a proton. This carbon-14, ito ginagamit sa mga carbon dating natin. This is how carbon-14 forms. I don't know if we can actually use this as a nuclear transmutation, but yes, because of this one, this process. So next, ito naman yung sinasabi ko kaninang reaction to the surface of the sun. Actually, hindi lang sa sun siya present din siya sa surface ng mga stars sa universe. So we have here a hydrogen reacting with hydrogen to form a deuterium. This one is a deuterium here, a 2H. And this reaction actually yields one proton. Tapos, chain reaction, so yung na-form natin na daughter nuclide na deuterium, itong 2H, nagre-react yan sa isa pang hydrogen to form a helium isotope. This one is a helium isotope. This helium isotope reacts with itself, so isa pang helium isotope to form a helium atom. So this chain reaction is a nuclear transmutation happening on the surface of the sun. Oh, there you go. Nasa taas na yung ginagamit sa carbon dating. Okay. So modes of radioactive decay. So let's talk about radioactive decay muna. Okay. Modes of radioactive decay. So mode of radioactive decay. So we have here 6 modes of radioactive decay. So we have alpha, beta, gamma, positron, electron, and spontaneous fission. This one, the electron emission and positron emission, they are actually correlated with each other. Okay, so let's talk about the alpha decay first. So alpha decay, or this one, alpha decay, is a type of radioactive decay in which the atomic nucleus emits a helium nuclei, dapat nuclei ito, thereby transforming or decaying into a new nucleus. So simple lang naman to. If you see this alpha, this one is called an alpha particle. Nakita na natin yan kanina. Nakita kayo ng alpha particle as a daughter, not parent, daughter nuclide. This is an alpha emission, aka alpha decay, aka alpha emission. Okay, basta present siya. So So there is an alpha emission. So meron actually ako 3D model kung ano ba yung itsura ng alpha particle. So actually helium lang yan. Helium nuclei lang siya. So that is the nucleus of a helium. And makikita natin here, meron siyang 2 protons and 2 neutrons just like the helium. Next is this is the general reaction of the alpha decay. Here, beta decay. There are 2 types of beta decay. Beta minus, which states that an electron is actually emitted from the nucleus. So, di ba medyo weird because electron is we find electrons dun sa mga part ng ano di ba? Sa part nung sa outer shell nung outer part ng ating nucleus. However, bakit manggagaling sa nucleus yung electrons? It's kind of weird, pero may explanation dyan. So we also have a beta plus or a positive emission. A positive electron is emitted from the nucleus. Actually, merong explanation why. Because in the beta minus decay, itong beta minus decay, a neutron decays into a proton. So this one, ang nangyayari dito is a neutron decays into a proton. Bakit? Nangyayari yung beta minus kapag masyadong marami yung neutrons. Okay? Because that neutrons is actually converted into protons. And yung mga protons kasi natin, binubuo sila ng mga tinatawag natin na elementary particles. And then, in the result, magre-release yan, yung conversion na to, magre-release yan ng electron, E minus, or ang tawag natin doon ay beta minus. Ibang box kasi beta minus, but it's technically an electron and an antineutrino. An antineutrino is an electron particle, is an elementary particle too, but that's not our concern here. We are concerned with the subatomic particles. So in a beta plus, can I say it is the opposite of beta minus? Well, some sort, yes, because in here a proton is actually converted into neutron, and this conversion releases an electron that is positive. Ang tawag natin doon ay beta plus. Electron na positive. Paano nangyayari yun? Ang tawag sa ibang box dito ay anti-electron. No? Anti-electron. So kung meron tayong electrons, meron tayong anti-electron. So ganyan some sort dun sa elementary physics natin. Kaya nga lang hindi natin concerned for now. So dito, ang ilalabas is positive electron. Ang symbol niya is B+. Actually, ba't ba? B+, dapat nasa taas yun. Sorry. Let me rewrite this one. Let me rewrite. It is actually written as beta plus here. Nasa taas. So, an example of here, so meron tayong beta plus. I think this one is called positron particle. And so positron particle is actually a beta plus particle. So again, nangyayari ang positron particle kapag nagko-convert tayo ng isang proton into a neutron. So kung mapapansin natin, kinonvert yung proton into neutron. Tingnan nyo to. Itong Z. Yung Z niya bumaba. Because it turns into a neutron. But titingnan natin, the atomic weights is still the same. So evident na nangyari nga lang dyan is conversion. So this is the general reaction for the beta plus decay. So magma-minus 1 dito sa part ng daughter nuclei. And we have the beta minus. This one is beta minus or beta minus particle or the electron. Beta minus particle. So Ang nangyayari sa beta minus particle is, di ba, conversion ng neutron into proton. So, nadadagdagan yung proton natin. So, kung titingnan natin to, nag-transform siya into 7. So, there is a conversion na nangyari. But kasi kung mapapansin natin, the same lang din naman yung Z. Ay, yung A pala, sorry. So, that is your beta minus. And this is the general reaction for the beta minus decay. So, dadagdagan ng 1 yung ating atomic number. So, let's move on. Let's talk about gamma. A gamma decay is relatively easier. Madali natin siyang makikita. Bakit? Kasi a nucleus changes from a higher energy state to a lower energy state. So, ang nangyayari dito is kapag ang isang nuclide natin ay excited in the sense na marami siyang energy. So, di ba, napag-usapan natin kanina na mas gusto ng ating nuclide na mababa yung energy niya or stable siya. So, ang nangyayari doon is inire-release niya yung energy na yun in form of photons. This is called a photon. Electromagnetic radiation. The number of protons is in the nucleus does not change in the process. It doesn't change still. So, parang nag-release lang siya, nag-bend out lang siya ng extra energy. So, this one actually represents the excited state. Tapos, nag-transform siya into a dysprosium 152 na wala na yung asterisk because nabalik na siya ulit sa ating relaxed state. So, this one, relaxed na ulit siya. So, ang tawag ng iba dyan is ground state. This one is called a photon or simply gamma particle. Wala naman siyang effect dun sa A and Z. But, it really may meaning siya. So, yun nga, yung natin to vent out those energy in form of EMR, electromagnetic radiation. The gamma decay, this is a general reaction, so same lang, wala naman pagbabago. Okay, next is the spontaneous nuclear fission. A massive nucleus undergoes spontaneous nuclear fission. The massive parent nuclide splits into two daughter nuclei. So, together with other subatomic particle with lighter and similar mass, this is prominent with nuclides with Z is greater than 104. So, kung mapapansin natin, this is prominent. So, meaning, yung relatively smaller than Z greater than 104, it may undergo spontaneous fission, nuclear fission, but this process is prominent o mas noticeable dun sa mga C na greater than or mga atomic number greater than or equal to 104. So, medyo malalaki na to ng mga nuclei. So, ano ba yan? Yeah, that's what I'm talking about. Hindi kasi lahat na to. So, meron tayong larger one. Basta, this one, katulad na to, this one is less than 104 but it undergoes a spontaneous nuclear fission. So, this is caliform yung 254. So, it splits into a palladium 118 and tellurium 132 and 4 neutrons were ejected in the process. Kung mapapansin natin, nag-i-split yung in a spontaneous nuclear fission, they tend to split into two or more daughter nuclides. At kung mapapansin natin, yung daughter nuclides natin have fairly similar atomic number and atomic weight. So, one good prediction here is yun nga, kapag nag-undergo sila ng nuclear fission, they tend to chain out, no? There is actually other modes of nuclear reaction, an electron capture. So, in an electron capture, baliktad nga lang siya. An unstable nuclide can also undergo electron capture to transform itself into and become stable. So, ang ginagawa natin is, diba, ito yung nucleus natin. Ito maliit. Pwede ba mag-zoom dito? Let's try that. Ito yung ating nucleus. Itong nasa gitna. Ang ginagawa niya, huhugutin niya yung pinakamalapit na electron sa kanya, which is the inner shell. Tapos, ang gagawin niya, i-convert niya yung electron na yun into something. It may be transforming that electron into proton. Ganun. Para lang maibsan yung stress, kasi kapag pag kunyari mas masyadong maraming neutrons o masyadong maraming protons, meron kasing stress yung ating nuclide. So, ang tendency to relieve that stress, pwede siyang mag-add ng isang nucleon o ng isang particle o ng isang subatomic particle sa kanyang nucleus, or pwede rin siyang mag-alis o mag-transform into another one. So, yun ang ginagawa ng ating mga nuclides. So, and that is actually represented by this stability band. This is called a stability band. Kung mapapansin natin, ito yung mga ito yung mga mga atoms. So, kung mapapansin natin, this is the stability band. This is the 1:1 stability band. So, lahat ng tatama dito sa line na to ay stable. So, ang tendency nila is hindi ganong ka-harsh yung kanilang nuclear reaction. But, kung mapapansin natin, yung mga atoms natin habang tumataas, ay lumalayo. Lumalayo siya dito sa stability band. Ito, nag-start siya dito. So, kapag nag-start siya dito, lumalayo na siya ng todo. Especially dun sa mga kapag tumaas na siya ng yung atomic number ng 82. So, malayo na siya. No? Ito mga black na to, ito yung mga stable nuclide natin. So, pretty much maganda yung kanilang proton-neutron ratio. So, walang stress, hindi yung type na masyadong maraming proton, masyadong maraming neutron. So, balance lang siya. So, ayan. Ito, huwag niyong kakalimutan itong bang particles and nuclides na to. So, we have here the alpha. Ang alpha contains 4 and 2. The beta minus atomic weight is 0, but it has a negative 1 atomic number. So, yung beta plus is +1 and 0 din yung atomic weight. Yung gamma, walang effect, that's 0, 0. Yung proton is 1 atomic weight and 1 atomic number. Yung neutron, wala siyang dagdag sa atomic number, but it has a weight of 1. And electron is actually basically the same with the beta minus. So, let's try to solve some problems with nuclear chemistry. So, balancing nuclear reactions tayo. So, let's try to solve some real world problems na. So, dito na mag-a-apply yung ating applications. Dito na mag-a-apply yung ating skills. Pagpabalance ng nuclear reactions. Yung actual application natin. So, let's try. But first, why we need to balance? So, nucleons were conserved in a reaction. So, like the chemical reaction. A chemical reaction kasi is we assume that we take into consideration the conservation of mass. No atom was destroyed or created. So, before reaction, equal lang siya doon. The same lang siya with the after the reaction. Balancing nuclear reactions can be utilized to predict the daughter nuclide. So, kung hindi natin alam kung ano yung daughter nuclide natin, pwede natin gamitin yung balancing. We can also use balancing to determine the parent nuclei. Kung hindi natin alam yung pinaggalingan niya na nucleus, so we can actually predict that. Okay, so the key points here is, before balancing, we need to take into consideration that the sum of the atomic weight of A and atomic number Z is conserved throughout the reaction. So meaning the same lang siya. So from the sum of the A from left equal to the right, so and so forth in C. The atomic number will determine the identity of the nuclei. Yeah, alam natin yan. Coefficients can also be present in the reaction. So next, so this is the sample problem natin. So we have here yung kanina, yung californium. Let's take a look muna pala dito. This is an example. So kung mapapansin natin, I made a imaginary grid here because we want to separate the above, the atomic number with the atomic weight. So ayan, yan ang ating designation. So yung mga reds, atomic weight, yung green, atomic number. So separated by actually a arrow. So ayan, separated dapat siya. So let's look at the above part. So if we look at the atomic weight, the total weight of A on both sides should be equal. Kapag ka pinag-plus mo yung atomic weight sa right, ay dapat equal siya sa left. So in this part, pag pinag-add natin yung 118 plus 132 plus 4 times 1 because meron tayong coefficient na 4, dapat ang sagot mo dyan ay 254. So let's try to do that. So that's 254. I'm sorry. 118 plus 122 plus 4. Yeah, that's 254, right? Okay. So try naman natin yung baba kung the same ba. So pag pinag-add natin yung nandito sa kanan, the same ba? So let's check kung tama ba yung nakuha natin. So that is 46 plus 52. Oops, 46 plus 52 plus 4 times 0, 98. Yeah, 98. So that is relatively correct based on what we mentioned. So ayun. So let's try to make ito naman, encounter tayo ng iba pang problems dito. Okay, let's try to do balancing nuclear reaction as an example for this. Okay, so here we have thorium-232, which undergoes fission because it releases an alpha decay, and beta. So problema natin is to know this, or we need to know this ZYX, no? So how can we actually do that? So we are applying the principle that is the nucleon should be conserved throughout the reaction. So in this part, so we need to get this one, we need to equate. So here we have 232. That's 4 plus 0 plus Z. Actually, pwede natin gawin is parang ita-transform natin siya into an equation. Tapos, combine like terms, kasi iwanan natin yung unknown. So that's 232. Tapos, pag pinag-add mo yung 4 plus 0, that's plus 4. And then, i-move natin siya doon sa kabila. Magiging iba yung sign niya. That's 232 minus 4. May iwan yung z dito, di ba? So, 232 minus 4, 228. Right? This one, ito naman nasa baba, let's do. So, this is 0 to h. Nasa baba, let's do naman. So, that's 90. Let's do 2 minus 1 plus 5. No, plus 1. So, it's 2 plus 2. 2 plus minus 1. So, that's 1 plus 1. So, let's move this 1. Ito, magiging minus 1. Change the sign. So, that's 89. And plus y. So, ang value ng y natin is 89. So, this y is actually 89. So, now, we need to know the symbol of this x. So, we have actually a periodic table here. So, gagawin na lang natin is just click it. Let's check the atom that has an atomic number of 89. So, that's actinium. So, let's try to confirm na actinium ba siya. So, ang 89 ay nasa bandang baba. And there you go. Tama, actinium. So, tara, balik tayo. Yan. So, tama siya. So, example 1, we actually solved it. Next is, let's try to answer this one. So, ito, medyo binigyan na tayo dito ng clue because alpha. So, alpha has 4A and 2B. So, ang gagawin na lang natin, we will just need to solve for the x, no? Just equating it. So, starting by 252 is to, that's 2 times 4, no? Dahil may tayong coefficient. So, 2 times 4 plus z. And, so this 2 times 4 is 8. So, we need to move this 8 dun sa kabila to get the z with the unknown. So, 252 minus 8. So that's 244, right? 244. So yung z natin is let's see. So ang z natin ay 244. Huwag kayo ma-confuse dito dahil ito lang siya. So next natin is yung nasa baba. So that's right. We have here 95 is to 2 times 2 plus y. So that's 4. 95 plus y. So move natin to dun sa kabila. So that's 95 minus 4 for y. So 95 minus 4, that's 91. So we will be looking at an atom that has an atomic number of 91, no? Let's check the periodic table. So 91 is here, protactinium, Pa. So let's check. Yes, that's correct. We get the protactinium, Pa. Okay, next. Example number 3. So, eto baliktad. Ang hinahanap naman natin dito is the parent. So, binigyan tayo ng mga daughters. So, ang daughters natin is alpha, beta minus, and hafnium 181. So, ang gagawin natin, we are just solving the y and x dun sa parent nuclide natin. So, let's solve. This y is to 4 plus 0 plus 181. So, pretty much pag-a-addin nyo lang, napakadali. So, that's y. Getting you 185. Next is x. So, that's 2. So, minus 1 plus 72. So, that's 2 minus 1 is 1 plus 72. So the X is 73. So this one is 73. So ang paghahanapin natin is 185, 73. So let's try to consult the periodic table. So anong atom yung merong atomic number na 73? 73. Where are you? There you go. Tantalum. Tantalum is atomic number of 73. So let's check kung tama ba. Tantalum ba? Yes, tama ang ating sagot. So 185, 73. So next, another set of problems. So we have the determining unknown nuclei. This one is pretty much easier because we need to know the atomic number of that. So, di ba? Ang pinapasolve sa atin ay what? And determining the unknown, meaning we need to know the symbol or what type or what nuclei is that. So, madali lang naman siya. So, how can we go to this? Go on to this. So, let's start with 2. That's just 2. And by the way, we are solving for the y. Kasi hindi natin pwedeng kunin yung x, diba? We need to know the y first. So, we need to solve the y. So, that's 2 plus 2 times negative 1. So, that's minus 2, ano? Oops. How can I undo that? Erase ko muna. This one plus 84. So, that is 2 minus 2 plus 84. So that's 2 minus 2 is 0. 0 lang. So matitira is 84. So that's y is to 84. 84. Right. So this one is 84. The question now is, anong atom ang mayroong atomic number na 84? 84. Let's check. Yun. Ito, kita ko na. Polonium. Polonium 84. So, that, technically, the same lang siya with the polonium on the right. So, let's check. Okay. The answer is correct. So, we have 84 polonium. Next. Example 2. Dito, dalawa ang unknown. Kaya nga lang yung isa ay binigay na yung atomic number. So, we just need to solve for the atomic number nung nasa left to get the identity of the nuclei. So this one, 20, we need to look for the number 26 muna, no? Anong atom ba yung atomic number na 26? So, 26 here. So iron, ito iron. So let natin that this one is iron, Fe. Okay, so next we need to solve for the A here to get the x. So it's a 1 plus 26. Wow, simple math. 1 plus 26 is 27. So we are looking at element with an atomic number of 27. So let's consult the periodic table. Where is 27? Here, cobalt. So the cobalt here, this one should be cobalt. Cobalt, this one is 27. So let's check. There you go. You are still correct. Next, we have this is plutonium. Yeah, this is plutonium. So we have here a plutonium that is actually undergoing a nuclear reaction that yields an X42 and 234A. Di ba medyo familiar yung X? This one is actually alpha. This one alpha is 42. So very simple. We just need to get the A and then we solve for the Y. So it's 94 equating into 2 plus A. That is our unknown. So simply to get the A, we need to transpose the 2 on the left side, which becomes negative. Oh, sorry, that's 94. 94 minus 2. Okay. 94 minus 2 is 92. Okay. So meaning this A is actually 92. Now, anong element ang mayroong atomic number na 92? Let's check the periodic table again. There you go. Uranium to 92. So let's go back. So this one, according to the periodic table, this one is a uranium 234. Let's check that is correct. There you go, uranium and alpha. So, yun. Okay, this one, medyo mahirap ito dahil we need to transcribe keyword problems into a nuclear reaction. So, the production of 170, I think that's not 170, that's oxygen 17, sorry. Let me change that muna. Let me change that earlier, okay? Tama na siya. So the production of an oxygen 17, okay, ito, nasabi natin, this is an oxygen 17 but there is no atomic number given. To know the atomic number, you just need to look at the periodic table. That's the way to go. Next is from N. So we are looking here at the production of oxygen 17 from nitrogen 14 by alpha particle bombardment. So in this reaction, we are bombarding, or we are hitting an oxygen 17 with an alpha particle. So we are starting here from oxygen 17 according to the problem, right? So we will write that as a parent nuclide. So that's oxygen 17. And then you need to look at the periodic table. What is the atomic number of 17? No? I think the atomic number of 70 and of oxygen pala is 8. And then, oops, kasi nag-bombard daw siya with an alpha, so this one should be plus alpha, so because of the bombardment, bombardment of an alpha particle dun sa oxygen 17, so that's 4-2, no? And this reaction yielded 4 nitrogen, which is 7, right? And then, in consequence, we need to balance. This is actually what is on directly stated, kung ano yung directly stated sa kanya. So, the question now here is it balanced, diba? Hindi naman. So, in order for this to happen, so, meron tayong ilang assumptions here. Number one is that the alpha particle doesn't react to the nuclide. So, this one is actually conserved throughout here. So, during a bombardment, we assume that there is no reaction, so we can actually cancel out this one. No? So, ang mangyayari na lang is, ano ba yung pwede nating, yung pwedeng present dito. So, Ang natitira na lang sa atin ay if we take this one, divide the 17, and then we have here the 14. So, kulang pa tayo ng 3 atomic number and 1. Diba? So, ang designation natin dito is pwede ito depende doon sa ating mga fragments. So, pwede maging mga fragments dito is like 1 proton. I can see 1 proton here. Ang proton ay, babalikan nyo yung ating presentation here. 1 proton here is actually 1 proton and 2 neutrons. Ang 2 neutrons is 2 and 0. Ay, sorry. Ang 1 neutron ay 1. And then 0 neutrons. So, sir, you might be asking, sir, paano nangyari yun? No? Kasi, during a bombardment, this is an induced reaction, no? During a bombardment, we assume that the bombarding particle is not reacting with the nuclide, so wala siyang effect. So, present siya dun sa parent, present din siya dun sa daughter side. So, that is actually cancelled out. So, ang matitira nga lang is yung fragments natin. So, yung fragments na natitira is kasi, bakit may mga fragments? Kasi kung makikita natin, hindi siya balance. So, 17 sa left and 14 sa right. Kasi, if we are considering a nuclear reaction, dapat balance siya all throughout. So, this here is the possible nuclear reaction happen. Kasi, upon bombarding, di ba kapag nag-bombard tayo ng mas malaki, nag-i-split siya into maliit tapos yung ilang fragments. So, this one, it makes sense, yes. But, hindi lang ito yung pwede niyang mode of nuclear reaction. So, marami pang possible. Basta, as long as we are obeying the rules that number one, the nucleons or the particles are conserved all throughout. So, ayan. This one, example number 2. Ito medyo mahirap. Technetium 99 is prepared from molybdenum 98. So, molybdenum 98 combines with a neutron to give molybdenum 99. Ako, maraming reaction, no? And it's an unstable isotope that emits a beta particle to yield an excited form of technetium 99 represented as Tc, tapos may asterisk. This excited nucleus relaxes to the ground state represented as technetium 99 by emitting a gamma ray. The ground state of technetium 99 then emits a beta particle. Write the equation for each of these nuclear reactions. So, ang dami natin dito process. So, may tayong 1. Here, molybdenum combines with a neutron to give a molybdenum 99. So, let's do it one by one. So, the nuclear reaction on the first one is molybdenum 98 combines with a neutron. So, we have here a molybdenum 98. So, ano ba ang atomic number ng molybdenum? Let's check the periodic table. So, the molybdenum here is, asan ka? Here, 41. 42. Ito. 42. So, sabi niya, the molybdenum combines with a neutron. So, ang neutron natin ay 0, 1, diba? And this one yielded a molybdenum 99. So, that's pretty much straightforward, no? So, molybdenum 99. Is it balanced muna? Yes, kasi 98 plus 1 is 99. And 42 plus 0 is 42. So, this is the equation 1. Next, an unstable isotope that emits a beta particle to yield an excited form of technetium-99. So, this molybdenum 99 is an unstable isotope daw. Unstable meaning hindi siya stable, mataas ang kanyang energy. Tapos nag-e-emit siya ng beta particle. This beta particle actually is present, we refer to it as the beta minus beta particle. Meron tayong beta plus. Ang tawag sa beta plus, guys, ay positron emission, by the way. Yun yung nakalagay sa ibang books. Tapos yung beta minus naman is yung beta emission o yung beta particle natin. So, number 2. The second is this molybdenum 99 daw. Nag-e-emit siya ng beta particle. So, hindi siya present doon sa parent. Nag-e-emit So, nandun siya sa daughter. So, beta. Diba charge na? -1, 0, diba? Tapos, yung reaction nun, nag-yield siya ng excited form ng technetium-99. So, we have a technetium-99 here. Technetium-99. What is the atomic number of technetium? Technetium is 43 here. So, let's go back. Check na natin kung balance. So, 99 plus is to 0 plus 99. So, balance 99, 99. Ito, minus 1 plus 43 is 42, right? 42 nasa left. So, it's balance. So, this, sabi niya, excited daw to. So, dapat meron niyang ganyan pagka-excited form. No? So, next equation. This excited nucleus relaxes to the ground state. So, kapag nag-relax siya, anong reaction niya? Gamma emission na. So, ito daw, technetium-99 na to ay nag-undergo ng relaxation. Pag nag-undergo siya ng relaxation, inilalabas niya yung energy in form ng gamma. Gamma natin. Tapos meron siyang asterisk plus the original one dahil wala naman siyang effect doon sa nucleons natin. So, by emitting a gamma ray, yun nga naman pala. The ground state of technetium-99 then emits a beta particle. So, etong ground state daw na to o yung relax ay nag-e-emit pa ng beta particle. So, susulat na naman natin. Kapag sinabing nag-emit, saan natin siya ilalagay? Hindi sa parent side, kundi sa daughter side. So, nag-emit pa siya ng isang beta particle. So, that's minus 1, 0 plus okay, so what is the final product here? So, walang binigay na kung anong final product. So, designate natin siya as expo na siguro. Wala siyang binigay na final product, but syempre, we can balance this out, diba? So that is 0 plus, sige, let's say this one is 8, this one is 8. This one is 0 plus 8. This one is 99. So, since plus 0, ano ang value ng 8? So that's 99 minus 0 is 99. So this A is also 99. Next is B. Yung B natin is actually 43. Ito minus 1 plus B. So, pag minove natin itong minus 1 na to sa kabila, magiging plus. So that's 43 plus 1. That's 44. Yung B natin. So, 44. So, ang tanong, anong element ito? So, let's check the periodic table. Ano ba yung element na may 44? Yun, ruthenium. Itong ruthenium. So this one, the X here, yung unknown natin is the final product is a ruthenium with a ruthenium 99. Yun. So ay, hindi siya. Okay, last one. This is the last example. Lead 208 undergoes radioactive decay, which is a series of reaction involving stepwise emission of alpha, alpha, beta, and alpha. So, stepwise emission daw. So, sunod yung ibig sabihin, after one decay, another decay happens. Then, another and another. So, this time, apat yung ating modes of decay. So, alpha, alpha, beta, then alpha. So, there are 4 steps here. Paano natin siya gagawin? So, let's try to write the lead muna. So, let's try to know this. So, ang lead ay PB. At 208 kaya nga, let's try to search for the atomic number of lead. There you go, 82. That's 82. 82. Tapos, there are 4 modes of decay here. So, we have alpha, alpha, beta, and alpha. So, let's do the first alpha. So, the first one is actually emission decay. So, 1 alpha, that's 40. And then, ano yung product na to? So, that is, ima-minus natin to doon sa 208. So, gawin muna natin siyang X. So, 4 minus 208. Shortcutin ko na ha. 4 minus 208 is 204. And 82 minus 2. So, that's 80. There you go. So, ang tanong, anong atom ang mayroong 80? So, ito yung first na daughter nuclide natin, 80. Where is 80? Oh, mercury. Okay. So, this X here is mercury. That's our first product. So, first, number 1. Number 2. Yung mercury na yon, yung gagamitin natin to form the next. Yung mercury naman na nagawa natin ng first one is yung gagamitin natin to undergo the alpha naman. Kasi pag once na yung isang lead ay nag-undergo ng alpha emission, hindi na siya lead pa. Alpha na siya. Ano na siya? Mercury. Kasi yun yung product na na-form natin eh. Diba? Makes sense. So, 204, that's 80. Tanong is, ano kaya ang mapaform natin? Next, second mode is alpha. Another alpha na naman, power 2 plus. So, shortcutin natin ulit. 4 minus 204. So, that's 200, right? And then, 280 minus 2. Okay. So, that's 78. Sorry. What is Hg? That's Hg. What is 78 pala? Yun, platinum. Okay, from this point, so yung platinum natin, which is 278, mag-undergo yan naman ng beta emission. So, beta minus. Ang tanong, ano yung product niya? So, balance. So, eto. Shortcut natin ulit. So, 200 minus 0. So, retain. 200 pa rin. But, here, we have minus 1 and 78. So, pag minove natin yung minus 1 sa kabila, magiging positive. So, that's 78 plus 1. So, magiging 79. So, ang tanong, anong atom ang mayroong atomic number na 79? Gold. A. So, trivia lang ano. Bakit kaya A yung gold, hindi Geo? Kasi yung gold ay nanggaling sa Latin name na aurum. Trivia. So, next is alpha decay. So, we are starting with the gold one here. So, the gold is 279 gold. Alpha emissions 42 plus anong product kaya ang ating mabubuo? So, shortcut ulit. So, 200 minus 4. So, that's 196, right? And 79 minus 2, that's 77. Anong atom ang mayroong atomic number na 77? That's the question. So, let's look. Iridium. So, the final product here is the iridium. So, ito yung stepwise reaction na nagaganap kapag binigyan kayo ng mga problems nito. So,
Anong tawag sa mahirap na vampira?
Ano?
Bam lang kasi wala siyang pira. Oh. Alam mo ba kung sino nakatalo kay Darak? Ha? Sino? The paper. Oh. Alam mo bang malapit ka ng yumaman? Ha? Paano mo nasabi? Pera na lang kulang. Oh.